Thanks everyone for joining. I'm going to talk about how we did the rethinking of the Spotify Home and how testing techniques and code design help us reshape this feature. So first, a little bit about me. I'm Daniel Horowitz. I'm working on Spotify for almost 2 years now. I live in Spain, but I'm actually from Brazil. And this is the agenda for today. So we're going to talk about this. What is the actual Spotify Home feature, how the migration project came to be and what it is about. And also I'm going to build a bridge of something that I found out along the way, along this migration project, about code design and testability. But before I start, I wanted to show some appreciation for my teammates. The project described here is our company-wide bet, and it was not only made by me, but many other teams were involved. So I really want to say a huge thank you to everyone involved in this project. So yeah, this is a quote from Phil Jackson, the legendary basketball coach. And also another disclaimer before we start. So in this presentation, I tried a little bit messing around with AI image generation to kind of illustrate the ideas in this talk. So I hope you find it interesting. I also put the description of the prompts that I use. I hope you guys enjoy it. So what is the Spotify Home, right? So Home is the entry point for every journey of each user. Is where people come to find out what to play, and whether it's your favorite content or if you are trying to discover something new, Home is where you find it. So this is how Home looked like when we started the migration project. And as you can see here, we were just releasing the DJ feature. We had this cool cards with video that we were just launching then. And as you can see, the structure of Home here, we have on the top the filters. And when each filter is selected, this is what we call the sub-feeds, right? So you're filtering the feed of music and audiobooks and podcasts. So, but actually, what is the purpose of Home, right? So the purpose of Home, we have these 3 different types of user input, user interaction, sorry. And the Home needs to distribute like different types of content to every user. It needs to gather input from the user to optimize the recommendations and personalization of the users of Spotify. And also needs to enable the retrieval of familiar content, but also the discovery of new things, right? So we have around 600 million active users. And out of these 600 million active users, Home is the most used surface by more than half. So you can imagine like how many users we have going around Home. We have billions of daily impressions with these elements that you can see here. And also 80% of the streams come from recommendations. So this is like a core experience of Home. And this is how Home is showing the importance of this feature. But nothing is perfect. We have some limitations as well. So we had a component-centric architecture. So we didn't have communication between the components, which made some of the requirements to be unsolvable. We had a local tech stack. So many custom technologies were built for Home, which increased the cognitive load. So when someone new starts to work on Home, they need to get acquainted with this local tech stack. And because of that as well, we couldn't leverage like new technologies, new frameworks coming from internally, or also from Google, or new things from Android, etc. We're also using server-driven UI, which limit the interaction between the components. We wanted to have more lazy loading and interactive content in Home. And this time, this trade-off made sense. However, since we needed a more dynamic and integrated UI, we wanted to move away from it. So also the repetition without specialization led to these implementations that are difficult to extend and maintain. In this illustration here, I try to represent the entropy increasing, right? So as you can see on the bottom, the elements are well defined, but with the repetition, it becomes chaotic and hard to deal with. So then it came the migration project. So the migration project is composed by these two different bets. So we wanted to migrate home to use new technologies and frameworks, and we wanted to use this reusable architecture. We were actually the second team using this reusable architecture inside of Spotify, but nothing is as big as home, right? So as you can imagine, this was a big bet for the company. So the goals of the migration of home are to have this dynamic user interface. We also wanted to have some content-aware and reusable features. We wanted to model the experience, not the current code. So we want to model how they work, how they behave, without taking into account the type of the content. We also wanted to increase the autonomy of the clients by doing server-driven, but not actually server-driven UI. So we wanted to tune it down a little bit. And also the reusable architecture, right? So the goals are to create a consistent and simple experience and to build system using common solutions. But we can explain this reusable architecture with these 4 principles. So let's go through them one by one. So here, we want to have a client-first experience, right? So we believe that we can do a richer experience by doing more of the work closer to where the product is consumed. So just like doing coffee, where you get, the closer you get to where the coffee is made, you get a richer experience. So we believe in this concept for home as well. We wanted to have a content-unaware architecture. So we wanted to design for abstract use. We believe that this simplifies both us and the life of our users. This also goes in line with less server-driven UI. So here the metaphor is a blender. So whatever the content you put, you always get the same result. So in this sense, I'm trying to illustrate here the content-unaware nature. And also, as a Swiss Army knife, we want our components to be reusable as possible. So we want to focus on efficiency, and also in an effort to reduce the entropy, we want to have these reusable solutions that we can use across different surfaces. And here, this concept is very interesting. I really like this illustration, that we have different types of data when we are dealing with this client-first architecture. So on the left here, you can see that we have this structural data represented by this blueprint of a building. So you can see like all the design of each floor and the structure itself. And on the right, we have the content, right? So what is in each floor and how each room is represented. So on the right here, we call this the metadata. So let's look at this with an example of these shortcuts that we have on home. So this is the Spotify audiobook subfeed, and let's zoom in a little bit in the shortcuts element. This is how the structure looks like. So we have here a very simple proto with just an item, an ID, and a bunch of children IDs. This is how the content looks like. And then each shortcut is represented by the metadata. Here we call them traits. So this is a shortcut card trait. And we have the representation of the image with an image URL there. We have the title. We have the navigation URI, and also which entity this represents by an URI. But also shortcuts, they can represent different types of entities, right? So before the migration, we actually have for each entity, so here we have playlist, podcast, album, artist. For each entity, we had a separate component. And during the migration, one of the most important tasks was actually to consolidate these components into one, trying to reduce the entropy. So what we talked before about repetition of solutions. So here we have like a unified component for shortcuts, fulfilling our principles, right? So now the shortcut component is only one, and it fulfills all of these principles. But let's take a deeper dive into the client first, because there's more to it. So here we have this concept about local decorations, right? So as you can see, we have this blue dot there, and also a progress bar. And this is not represented. If you take a look at the metadata on the right, this is not represented in the metadata. So how do we get this data, right? So we have this concept of local decorations and local services, where we fetch this data from the services, and we later show this to our users. So on client first, we use these local decorations to fetch the remaining data in order to render the entire experience. So in this case, we have the entity URI that the shortcut represents. We go to the consumption service. If another surface, like a different feature that the user was already seeing, had already this entity, so we get it from the cache, or we can get it from the network. And all of this is done by the client with this concept of local decorations. Okay, so how does this relate to code design and testability, right? So let me tell you a story. So everything started with this thing that we do on my team, actually. It's called the Focus API proof of concept. This was actually a huge result, a huge success, something that was a source of bugs and a very unpredictable system became something that worked really well and was not a source of bugs anymore. So we took the knowledge that we gained from doing this POC, and we tried to investigate more areas that we can apply the same concepts, and this led to more refactor and better implementation. So let's take a look at what is the Focus API. So here, as you can see on the right, you can see I'm scrolling through the feeds, and things are getting in focus, right? So this can be used by the developers that make their elements to know, okay, I need to play a video, or I need to cache this video because I'm the next one to be in focus. This is how the Focus API looks like. So it's just, the public API is just a shared flow, so a stream of events. And the events are also pretty simple. They just have an ID and a state. However, as you can figure out, there is some challenges with this, right? So Focus API, it's very difficult to test because it's very close to the UI, and it deals with lists and scroll interactions. The code is highly coupled to the UI, so whatever you are using, if it is a recycler view or lazy columns, it's very easy to get this type of code tightly coupled to the UI. Since it's dealing with scrolling, the code is very sensitive to changes. So adding code to wrong places could lead to huge performance issues or unexpected bugs. And it's a complex behavior, right? So also because of scrolling, the code can be executed many different times. We have the recycler view APIs, which are complex to understand, and the behavior is not what you could expect. We also have, like, if you put some code in the wrong place, can bring some performance impact, and the list goes on. So how can we make this code better, right? So the migrations normally, it's a good opportunity to redesign the code, and also to sometimes you are allowed to rewrite the code that you are doing, right? So in this was the case also for our Focus API. So how could we improve it, right? So what are the concepts that we can see that could improve this API? So we probably want to make more testable, more predictable, simple and intuitive. Normally, when I think about this, I think about, okay, so if I have this complex thing that I need to rewrite, I try to always start with a test, right? So, and Uncle Bob agree with us. So the act of writing a unit test is more of an act of design and of verification. So let's go back to Focus API and figure out what it's actually doing so we can write our first test. Okay, so Focus API is basically just, we have just a bunch of elements on a list, and we want to focus the first one that is X% visible, right, on the top. So how can we think about a good test, a good first test for it? So given initial state, When an item becomes visible, then it should gain focus and lose the previous one, if there was something else focused. So what are the components of this API? Right? So we talked about that we have some UI code there. That is the integration with the recycler view and lifecycle and etc. We have some focus logic. This is where we reason about the focus state. We have some action listeners. This is listening to scrolling, navigating, clicking, and etc. And we have the event generation. This is the Focus API stream. This is part of the public API, actually. And when I think about this, I think about we have an input, right? We want to do some kind of computation, and we want to have an output. Kind of like the given when then structure when you're writing tests. And in this particular case, what we have are some user or UI actions. We want to apply some logic, and we want to deliver some focus events. So the strategy that I used to improve this design was to first completely isolate the Android integration, then map all the actions to my domain knowledge, then apply some pattern like UDF and single entry point to handle these actions, and then generate the focus events. So if you think about it in more like a component diagram or system design, this is what we would end up having. So on the framework integration, we have the Android view that generates some UI or system actions. Then we send this to this entity called the focus coordinator. This coordinator is responsible for mapping this system and UI actions to domain actions. And now we are on the realm of our domain logic. Then we have this other entity that deals with all the logic, the reasoning for handling this focus state. And after that, we map these domain actions to events. And this is already the part that we expose to the clients, right? So this is the stream of focus events that we send to our client. So this is the end-up result of one of the many tests that we wrote for this. So as you can see, it's a very simple test. I cannot share all the code here, but you can get the gist of it. And we finally got a predictable system, and we could see that the design improved, and this was not a source of bugs anymore. And the design problems you find when writing tests first will force you to simplify and improve your code. This is a quote by Martin Fowler, right? But why does this, why is it true? Why do we get, like when we write tests, we are forced to get a better design? How does this happen? So there's this famous author called Michael Feathers that he talks about the deep synergy between testability and good design, right? He also has another talk that talks about fixing design with tests. So the first thing that he says is that every time you encounter a testability problem, there is an underlying design problem. So in one of these talks, he says that he annoys many developers because whenever he finds some test pains, he goes to this developer and says, hey, you have a design problem here. And developers don't like hearing that about their own code. So let's see what are the test pains that he talks about and how to fix them as well. So the first concept here of a test pain, I have this iceberg class. So an iceberg class has one public method and a bunch of private ones, kind of like an iceberg where most of its mass is underwater, right? And testing this kind of class is hard, especially if you want to test one of these private functions, right? So there are some chances that this class is actually doing too many responsibilities. So let's go through an example of this. So imagine we have this focus coordinator where we have these two public functions, attach and detach, and the rest of them are private functions. And these functions are called in this order. And imagine we want to test actually this calculate visibility function in isolation. So how can we do that? How can we improve the design that we can just test that function in isolation. So here, following this single responsibility principle, we can extract some of the responsibilities to different entities and actually move these functions to these other entities. So now we have a visibility calculator that is responsible for calculating the visibility. And we have a focusable view finder that is responsible for all views operations. So now, as you can see, we can actually test the calculate visibility function in isolation. So basically, the testability of the system has improved due to a design improvement as well. But if we go back to the previous design, right, the focus coordinator here, we could just make this function public, right? You can see that by this, we would actually make the code more testable. However, the design didn't improve here. If anything, it got worse now because you have two public functions, right? So making code testable does not necessarily make the design better. So let's go through the other example. So this one, unfortunately, I've seen this many times. I asked ChatGPT to generate a code of a view model that is commonly used. And I know all of you already saw like a view model like this that has many different dependencies. So this test pane is called the difficult setup, and you can instantiate a class that involves instantiating a bunch of others. You can see that there is a problem of a design problem here. It's probably there's too much coupling here in this view model. But you can only feel the pain when you actually try to create a test for this. And many times, this type of classes, they are not even tested at all. But you can solve this by factoring this problem into smaller ones. Like you cannot, doesn't matter the complexity of a problem, you can always make it, you can always factor it in smaller pieces. Yeah, so to solve this design problem, we need to have like a deep understanding of the business logic and how are the dynamics of the behavior and how it works. But for the sake of this presentation, let's try to understand what is this generated class doing and try to solve the problems here. So as you can see, it has a bunch of data retrieval calls here. So we have a bunch of repositories, services, and handlers and managers here. So it's doing domain logic as well inside this view model, and is also doing the external services integration. So we have authentication services, push notifications, and etc. So hypothetically, we could change this view model and extract them, and extract from it a domain logic layer where we could have some use cases, and these use cases would then invoke some data retrieval classes, and we could also build a data persistence layer here where we could call these data sources and then remove all the coupling that it had before with the view model. So then these repositories will be completely decoupled from all of this logic in the view model. For the view model itself, we could use UDF, for example, to map the user and system actions and convert them into states. So with this, we are also, again, following the single responsibility principle and fixing the design for this class. Another very common test pane is the framework frustration, right? So testing in the presence of a framework is very hard. So Android is a very common, you can find this almost everywhere. We saw an example with the Focus API. And if you try to concentrate on the domain and try to keep it separate from the use of the framework, then you worry about how to test the domain itself and worry less about the framework. So the problem here is that we have insufficient separation of concerns. And yeah, on Android, we often need to create abstractions and model more of our domain in order to extract our logic away from the framework and be able to test it. So let's see an example of this. So again, going back to the Focus API, let's say we want to calculate the visibility percentage now. And you can see that this code is highly dependent on the UI framework, and the logic is easily coupled to it as well. So how can we solve this coupling? So the idea here is to isolate, from one hand, the Android framework and the recycler view integration, and from the other hand, we would have the domain models and the calculation logic. One thing that helps me with this when I'm trying to do these separations, that if I think about writing tests for this, I think about how can I write pure Kotlin tests, or if you're working with Gradle, like how can this be a pure Kotlin Gradle module, for example? And this forces me to remove all the code and all the Android SDK dependencies and model as well the domain into Kotlin classes, into pure Kotlin classes. So here you can see some code for calculating the visibility. You can see that there is this function called get percentage of visibility that actually has Android SDK views there. But then on the bottom, we have our models, our domain model into domain classes. And this calculate visibility percentage is what is doing the mapping between the SDK and our domain modeling. So then, when we test the calculate visibility percentage, those are pure Kotlin tests, and everything is tested in isolation from the framework. Okay. So he also talks about fixing design with tests, and it has like different meanings of the word fix, right? So we already saw the process of fixing the software with tests, but there's also this concept of actually like securing in place a particular piece of code with tests. So let's see an example of that. So when we started the migration, we only had a single page to represent home. So pages is something that we use on Spotify as an internal framework. It's kind of like fragments. You can keep this on your mental model. So in the beginning, we only had one page. However, we wanted to make the migration in an iterative way and not make a big change. So one of the goals of the migration was also to not stop like the development of home, but actually do like a seamless migration for us and our users. So how did we solve this? We created this new page to be a host to the existing production page as a child. And every subfeed would be a different page. So we were able to roll out iteratively each page, right? But then we needed to have a way to make sure that the behavior was still the same, even though we were doing this migration and reusing this page in a different way that we were using in production before. So we had some end-to-end tests and also regression tests to kind of fix. So the word fix here is kind of like secure in place. So to fix the behavior and be able to iterate over the migration of home. So let's go through the final remarks. So with the migration, we had 75% less of components. So we had a huge decrease in the components, which is a major statement of the level of reusability that we achieved, and the entropy reduction that was also a goal of the migration. We also enabled more releases and experiments. So in spite of doing this migration, because we did it iteratively, we were able to not stop the experimentation of home, and we actually achieved more experiments than the year before, even though we are going through a migration. So this was a huge victory. And if you get out of this talk, you could get out with this information that I think is the most valuable thing, that it exists a deep synergy between testability and good design, right? So solving design problems solves testing problems. Making code testable does not necessarily make the design better, and testing is facilitated by the presence of good design. That's all. Thank you.